Hey there, algebra friends. So today we're going to figure out how can we find all of the zeros of a polynomial. Not just the possible ones, but every single one possible. And we know by looking at the degree of a polynomial, we have a pretty good idea of how many zeros we should find. For example, on this one, because the degree here is 3, we should hopefully find as many as 3 zeros. Here's what we're going to do. Now we don't have a starting point. We don't have anything like, well, I know x equals 2 is a 0. No, I don't know that. Oh, x minus 1 is a factor? No, I don't know that either. There's nothing to help us start. We have to start with a clean slate. So here's what we're going to do. First thing, let's try to get some clues about this. So we'll use our famous rational zero test to make a list of possible p over q. So we have a place to start. So remember, the p is always the coefficient at the end, the constant term, and the q is the coefficient of the leading term all the way in the front. So if I look at our p over q list, all possible factors of p's over q's. Well, let's take a look. All factors of the p here would be, for 9, would be 1, 3, and 9. And all the factors of the q here, the 3, would just be 1 and 3. So our full p over q list would be all combinations of the top with the bottom. For example, 1 over 1, 3 over 1, and 9 over 1. And then 1 over 3, and 3 over 3 I already have, and 9 over 3 I already have, so I don't have to list them twice. All right, so I have a list here. There's 4 of them, but because of the plus or minus, there's really 8 of them. So we have 8 possible fraction zeros that could be there. If we have any zeros of our polynomial here, and the 0 is a fraction or whole number, he has to be from this list. So now we sort of have a good starting point. And way back in the day, we would do synthetic division or synthetic substitution on all of these to see which ones work. But what we're going to do is we're going to do a little bit of a cheating shortcut. So on number 2, we are going to use our graphing calc, but just as little as possible. Just want you to pick one from our list of p's over q's up here that you also see on your graph. Okay, well, let's put this one on a graphing calculator. And when I do, he sort of looks a little bit like this shape, if you do it right. And so we want to pick one of these zeros here where it seems to be crossing that's also on our p over q list. It's always helpful to look for some whole numbers possibly. And it looks like right over here, it looks like it crosses at x equals 3, or at least touches it. So maybe there's an x-intercept or 0 at x equals 3. Now, the way to check those, we have to verify it by doing synthetic on it. Make sure it really does work, because maybe we were off by a little bit and the synthetic will tell us that. So down here, let's check if 3 is an actual 0. All right, let's see the coefficients we're going to use here. We have 3x cubed minus 19x squared plus 33x minus 9. No placeholders, so we're good to go. All right, now remember, if this is an actual 0, we should get 0 over here just to be safe. All right, let's do it. So we bring down the 3, we multiply, add down, multiply, add down, and multiply, and what do you know? It's an actual 0. We got a remainder of 0, so we can say that x equals 3 is a 0. We can also say it's a solution. We can say that x minus 3 is a factor. A lot of things come out of this. That's pretty cool. Okay, so we checked it, it worked, verified it. So in our list of zeros over here, we'll say, well, I know that x equals 3 is definitely one of them. Now, if by chance this was a higher power, like say x to the 4th or x to the 5th, we might need to go back to the graph and pick out a couple more. But because this is x cubed, our goal is to bring it down to some kind of x squared polynomial. Because once it's down to an x squared polynomial, all we have to do is just solve it by usually factoring and finding the rest. Well, these numbers, let's see what they actually mean, right? So we were dividing by x minus 3, or we did synthetic on 3, and this gives us a result of 3x to the 2 power minus 10x and plus 3. It is a quadratic, so we don't need to go back to the graphing calculator anymore. Let's just solve this as we have. All right, well, this factors beautifully. This should be 3x and x. We could do grouping here, but I have a feeling it's going to be 3 and 1 and minus and minus. And you can verify that by doing the grouping of factoring methods. All right, so therefore, x equals, from this first one, if this equals 0 and we solve it, x should be 1 over 3, and over here, x should equal 3. That is interesting because I got 3 twice, which means he actually has a multiplicity of 2. The factors would therefore be 3x minus 1, x minus 3, and x minus 3. Or, instead of writing x minus 3 like that, I could put it as squared. And look at that, it's got a multiplicity of 2. Do you remember when you graph these polynomials, if you have an even multiplicity, what does it do at that 0? And as you can see right here, it does bounce. Look at that. So math really does work. So on our list of zeros, do we have to write it twice? No. But if you want, you can say it has a multiplicity of 2 to show that basically that's almost like having 2 zeros, 3 and 3. And the other one came over here of 1/3. So 3 has sort of a multiplicity of 2. 1/3 has a multiplicity of 1. So we have 3 total. And that's how we found it. Were we given anything to start with? No. So you make your list here. And let's check and see. Right? See we have 3 here. 3 is in our list. Remember, we said 1/3 of it. There it is. It's in our list. So the ones that we found that are rational numbers or fractions are going to be in that P over Q list, and that's why we find it. Let's try one more. Let's find all the zeros of this friend. Okay, nothing to start with. Nothing to help you out. So you start with your P over Q list. Let's make a list of all the possibilities so we know some place to start. All right, my P over here is all the factors of 12. So 1, 2, 3, 4, 6, and 12. And then on the bottom, I want all the factors of Q. And Q is the 1 that's in front of the x cubed. That's pretty easy. It's just 1. So my full P over Q list would be, don't forget the plus or minus, because we could get some negatives, just everything over 1, which just gives us a bunch of whole numbers here. With the plus or minus, we now have 12 possibilities here that we can choose from. Why don't we go over to the graph and we'll take a look. When we graph this in our graphing calculator, how does this look? Well, let me put it in my graphing calculator and I'll see how mine looks. All right, on my graphing calc, he ends up looking something like this. A big swipe through, curving through, and this way. So my zeros are here, here, and here. And I just need to see any of those numbers, when I look really closely, are they on my P over Q list? And right now, it seems like it's slicing through a couple of choices here. Maybe even, oh gosh, it looks like it might even just going through x equals 1. I feel like x equals 1 might be one of them right here. And sure enough, it is in my list, so I'm going to test it. Whatever guess you take, just test it using synthetic. I'm going to try 1. All right, my coefficients here are 1x cubed, 0x squared. Did you catch that? 0 placeholder, negative 13x, and a 12. Let's see if this works. Well, look at that. Awesome. So 1 is indeed a 0. So I'm not going to use my graphing calculator anymore. I'm going to put it away. I don't need it. I'm going to do it all by hand because this means 1x squared plus 1x minus 12. I don't need the graphing calc anymore. I can just factor this by hand. Let's see. How about x plus 4x minus 3, I think? Awesome. So x equals negative 4 is a 0, and x equals 3. Go back to the top of your list with your p's over q's. Do you see how 4 with the negative is in our list and positive 3 is in our list? And just looking over the graph, do you see, not that we're going to use that again, but you can see there is where the 3 and there's where the negative 4 is. So we only need this really, this whole graphing calculator step, really only once to give us a starting point. And then after that, we're going to put it away and do the rest by hand. So my zeros. I know from the degree on top here, the degree is 3, so I should find 3 zeros, and I did. Look at that. I found x equals 1, x equals negative 4, and x equals 3. And those are all the real zeros. It's not asking for it, but if I want to write it out as factors, it would be x minus the 1, x minus the negative 4, which gives you a plus, and then x minus the 3. That's another way of writing your polynomial. So that's how we're going to graph polynomials by hand without using the graphing calculator to graph it, but just as a little tool off here on the side to get us started to help us find the zeros. Okay, that's it. We are good to go, and we'll see you next time. Great job.